Hi there, and welcome to the Writing Equations of Lines Introduction Practice Set. Give this video a like if you find it helpful and subscribe to the channel for more math help. Please drop a comment and let me know what you think. Without further ado, here are the practice problems. Pause the video to work these problems on your own and then come back to check your work. All right, so these first ones are ones where we are just writing the equation of line given like the slope and the y-intercept. And what I tried to do when I wrote this problem set was change up what they look like a little bit. So the first one is just really straightforward. M is equal to 3, B is equal to -2. So if you remember your slope-intercept form of a line, this is a direct substitution in. So y is equal to 3x, and then your b value is a -2. You can express that as plus -2 or as -2. Like either one of those are equally correct. Do whatever your teacher wants you to do. Now for the next one, I opted to use the vocabulary and I also changed the order. So sometimes we get so stuck in slope intercept, slope intercept, slope intercept, mx plus b, mx plus b, and the slope is always the first number that we see, and then the second number we see is the y-intercept, but there's no rule that says that whoever gives you a problem always has to give you the slope first. So in this one, I just changed it up so that the y-intercept was being the first number given and the slope was the second number that was given. The symbol for y-intercept is the b, and so when you see y-intercept, you know that's going to be the b, and the symbol for slope is the m, so that's a little bit more added information. And then I think it's always good practice to write down the form that you're going to use. Don't really need to, but it's helpful when somebody else is grading or evaluating your work. And so this becomes -4/5 x minus 3 or plus -3, whichever you would prefer to do. Now, this next one, again, trying to change this up because this is a very, very straightforward skill. Just trying to go through all the different ways somebody might give you this. And so this one says slope is 4. So our M is 4. And this time it says goes through the point. 0, 6. And you'll see that a lot in future problems when the point that you're given is not the y-intercept. But in this case, if you were to picture where is the point 0, 6, okay, it would be right there. And so this is another way of saying the y-intercept. So the y-intercept is the 6 because that's what will cross the y-axis. Now, not every time that you see a problem like that will the point being given the y be the y-intercept, but it's a good thing to pay attention to. And so we have y equals mx plus b. And so this will be y equals 4x plus 6. And we're done with the first 3 problems. Now on these 3, this was 4, 5, and 6. I did try to change these up a little bit as well. So the first 2, I put the dots on there. Okay, so we can take a look at those. So for the first one, it appears that the y-intercept is 6. And I would actually write that down somewhere, like write y-intercept equals 6, or b equals 6, or b equals 0, 6, like the ordered pair, something somewhere if somebody else were evaluating the work. And then the presence of the other point can make it a little bit easier for you to find the slope. So we're going to look between the 2 points and we're going to look at our rise over our run. And in this case, to get from the first point to the second point, I am going down 1, 2, 3. So my rise is -1 at -3, and I'm going over to the right 1. So my slope would be -3 over 1, or just -3. And plugging that in, we'll get y is equal to -3x plus 6. On the next one, similar deal here. We go and find the y-intercept. This time I'm going to write it as the ordered pair. Okay, the y-intercept is the point 0, 1. We don't ever want to lose sight of that. One of my colleagues does do that, makes their students write 0, 1, just to continue driving home the fact that y-intercept is not a number, it's a point. All right, so I'll just change it up in how I'm doing it. And then looking for that rise over run, we're gonna go connect these two dots and my rise. So we're doing rise over run. My rise between the 2 points, it appears to be 2, and then going over 1, 2, 3, 4, 5. So my slope would be 2/5. Y equals mx plus b, so y is equal to 2/5 x plus 1. Now on the last one, I did not put the dots on there, and I did that because so many times I have had students, I'll say like pick 2 points on the line, and they will look at this and they will tell me, but there aren't 2 points on the line. And what they're looking for is dots. They're looking for dots. And if they don't see dots, then what they're thinking is, oh, well, there's no points on the line. There are an infinite number of points on that line. You just need to find the ones that you're looking for. So looking first off, it appears that the y-intercept is 4. Okay, so right there, you know, that's the point 0, 4. So you can kind of connect like, oh, yes, there are points on the line. Now, this time it is up to you to find another point on the line. And you want to find something that's called a lattice point. You want to find a good one for finding the slope. So right there, okay, if you see where I'm hovering it, that appears to be a good spot. Now there are other spots that might work. It looks like we have a good spot down here, right there, going to the left also appears to be a good spot. Any one of those points will work. Okay, but I'm going to pick the one that looks the most convenient. And essentially we put our own dots on there. Okay, we put our own dots on there to find the slope. And so this will be the rise over the run. And looking here, it looks like this comes down 1, 2, and goes over 3. So my rise is -2 and my run is 3. So we have -2/3. Y equals mx plus b. So y equals -2/3 x plus 4. And that's how we would do it from the graph. Again, if you listen to the video, underrated skill. Like we just kind of forget that this is a thing that we can do. Now the next question, question 7, this one is intended to get you to notice something. So we're about to engage some geometry here. You are asked to write the equations of all of these lines. So we'll start with the red one. And the red one appears to have a y-intercept of -4. And looking to find another point on that red line, I see one down there. Okay, so my slope is going to be rise over run. So it looks like I'm coming down 1, 2, 3 and going to the right 1. So -3 over 1 or -3. So the equation for that line would be y equals -3x minus 4. Looking at our yellowy orange line, that one appears to have a y-intercept of 1. And then looking for another point on the line, I see one right there. So we're going to count and we're going to go down 1, 2, 3. And over 1. So we have y equals mx plus b, and so this one appears to be y equals -3x plus 1. Now you might be noticing something here, okay? And that's the intent, is to just notice something. So last but not least, let's take a look at that purple line. Purple line appears to have a y-intercept of 5. And the slope, again, looking for 2 points on the line. And I'm going to go this way. Okay. And it looks like my run appears to be a 1 there. And, well, kind of, yeah. And then my rise is down the 3. And so we have the -3 again. And the equation of the purple one is y equals -3x plus 5. And what I want you to notice there is that all of them have the same slope and that these are parallel lines. And so this is like a little bit of an investigation, just so you can kind of see that and discover it on your own. Parallel lines have the same slope. If they had different steepnesses, if some of them were steeper than others, then eventually they would intersect because one of them would be moving at a faster rate than the other. And this can come in very handy in what's called coordinate geometry, to write equations of lines that will behave a particular way. All right, last problem is number 8. So an international phone plan charges $15 to purchase the phone card plus $2 per minute that you talk. Now, I haven't traveled a whole lot overseas internationally, like since cell phones have become really, really common. It's been a few years, and we definitely had cell phones. But the last time I traveled overseas, it was still common to like purchase an international calling plan, and you could sometimes do that through your cell phone carrier, or you can go and purchase like a card that you can use, because if you were to go to like other countries, there's like AT&T and Verizon. Those aren't the phone companies in other countries. So those countries have different phone plans, and you're about to put your phone on their network. Okay. And so that gets a little bit complicated. It's not a normal thing in your phone plan. So you've got to call your phone company. You got to find out how they're going to do it. One of the things that you can do is buy like a card that would work internationally, and you'd purchase the card, and then that card will charge you a certain amount per minute that you talk, or sometimes you can preload it with minutes. Like there's different ways that you can do it. So this situation, it's going to cost you $15 to purchase the phone card plus $2 per minute that you talk. So I'm trying to walk you through this a bit. How much do you pay if you end up not talking at all? So you're going to go on like the mission trip to, I don't know, Kenya. Okay, you're going out there and you buy the $15 card, and then you end up not calling home. You're having a blast, you're busy working, you're doing this, that. Okay, how much do you pay? Well, you end up paying $15. Okay, if you do not talk at all because you purchased the card. Now, the second question is, how much do you pay if you talk for 16 minutes? Or it's not 16 minutes, 6 minutes. So if in that case, you're going to pay the $15 plus $2 for each minute that you talk. So you call home, you check in with your mom, hey, I'm having a great time, or hey, I got food poisoning. Like I don't know what you're talking to your mom about, but you're talking for 6 minutes, okay? And so that would be 15 plus 12, or $27. So the next thing that you're asked to do is go ahead and graph this. So I have the graph set up. Notice that we have it labeled. So we're putting the cost on the y-axis, that is our dependent variable, and our time in minutes is going on the x-axis, that is what's called our independent variable. So how much you are paying depends on how much time you talk. Okay, you talk more, you're going to pay more. You talk less, you're going to pay less. If you talk 0 minutes, you will pay $15, and you'd represent that by the point right there. So you end up not talking at all, you're out the $15. If you talk for 6 minutes, you are going to pay $27. So that's going to put us up here. And what you might notice is that is a linear relationship. Okay, and so there's your graph. Now, you might have switched the axes up. If you did, I wouldn't erase it, but I would make a note in the margin saying, ooh, I need to put cost on the y-axis and time on the x-axis. That is going to be like something that you would be marked down for if you get it wrong. Sometimes teachers will tell you how to set it up so that you make sure it's right. And then as you move further in math, you do talk more about the independent and dependent variables and why you put them on the x and the y axis. But if you did it backwards, just make a note to yourself, like I put these on the wrong axes, I should do it this way instead. Now that we have the graph, we can see that the y-intercept is 15. And so some questions might be asked, what does the y-intercept represent? If you were asked the question, what does the y-intercept represent? Then you would say the cost when I talk for 0 minutes, or the cost to purchase the phone card. Okay, that's what the y-intercept represents. Don't say the y-intercept represents where it crosses the y-axis. That's the definition, not what it represents. Now, to get the slope, we need to look at the rise over the run. So I'm going to kind of sketch that in. Okay, and my rise is going from 15 up to 27. So you might say, okay, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you might say that's easier to do 27 minus 15. Okay, that would also work. And then your run is going over 6. And so 12 divided by 6 is 2. Now you might have also done that by locating the coordinates of the 2 points. So we had the point 0, 15 and 6, 27, and you might have done the formula. Okay, now if any of that is like sounding stale, like, oh, I don't remember that, go back, check that video out. Okay, make sure that you're not forgetting the stuff that we've already covered. And now writing the equation of the line, y equals mx plus b, we have y is equal to 2x plus 15. Now, I mentioned earlier that the y-intercept represents the cost of the card, or the cost for talking for no minutes at all. The slope, you'll recognize that number from up there, that represents the cost per minute. So if this is the first time you've done a problem like this, then you probably need to go through all these steps. But for people that have done a lot of problems and are very experienced in algebra, they would actually be able to read the problem and immediately write the equation. Say that's going to be y equals 2x plus 15. Not because they are brilliant, but because they have seen this and they've seen that pattern of rate of change in y-intercept before. Okay, so if you had to do it the long way, that's totally okay. That's what's expected the first time you do it. All right, so that wraps it up. Please do not forget to like and subscribe for more math content. If you find the video helpful, if you find the explanations helpful, drop a comment. Let me know what you think. If I did something that was confusing and you're like, I don't know what you're talking about, drop a comment. Let me know what you think. And I will see you in the next video.